Welcome to another episode of Software Explorations, Concepts and Overviews, hosted by yours truly, Tech Coach Ralph. In today's episode, we are going to continue our series comparing Selenium, Playwright, and Cypress, and we are going to have an emphasis on test flakiness today. So hopefully you've been tuning into the live streams to see us go and implement automated testing on freemindrecovery.com. It is the startup by my good friend Calculus Coder. So we have been going through that and implementing some automated tests around the registration, and then we're going to do a login. So continuing with that, we're going to talk about test flakiness today. Talking about what it is, how the different um, automation tools handle it, and which one seems like it is the best candidate to do that. All right. So, and we've already seen some test flakiness doing the live streams, but let's get into like the definition of it and how to best handle it, which tool best handles it as well. Okay. So let's jump right into it. All right. So what is flakiness? All right. A test is considered flaky when it passes and fails across multiple retry. Um, it passes and fails across multiple retry attempts without any code changes. Right. So basically, to make it simple, you run a test, it fails. Right. You run it again. You didn't do any difference. Right. You just run it again. It passes. All right. And then you run it again, it passes again, and you run it again, it fails, and then it runs, it passes. Like there's no consistency to whether it's going to pass or fail, right? That is considered to be a very flaky test. Okay. And there's many different reasons that could be. And we'll get into it, but high level, it could be that the there's data that it's relying on that is inconsistent, or it changes, or you're not staging the right data, or it deletes, or it could be some type of timing issue where it's waiting for a button to be clickable or to display and it doesn't do it in time. So a few different reasons that it could happen, and you try to account for it. So let's find out a little bit more about it. Okay, as one of the Google blogs says, almost 16% of our tests have some flakiness associated with them. This is a staggering number. More than 1 in 7 of these tests written by our world-class engineers occasionally fail in a way not caused by changes to the code or the test, right? So the code stays the same, the test stays the same, and it can be a multitude of different factors, like I was mentioning. Like it could be through bad preparation of test data, or it can be through bad like code where we're not accounting for wait times and stuff like that. Okay. In one of the research, it was found that 72% of test failures are false positives. Think about all the tests that you have and all the test failures reported for each run. False positives consumes a lot of resources that could be dedicated to much more valuable work. And by false positives, that means it fails, but it should have passed. So now we're spending time investigating to see why did it fail? Is it a valid failure? We do some investigating and troubleshooting just to find out. We run it again, it passes, or we do it manually and it passes, and now we wasted a lot of time, right? So let's take a look at this, right? So failed false positive. A failure of automated tests occur when the software is even functioning properly, right? So the software is working, but it's reporting a failure for whatever reason. 33% automation issues, maintenance, and flaky tests, right? 28%. So that's what I was saying here, right? So automation issues. So 33% of those of the 72% is um 33% of the 72% is automation issues like maintenance, like we're not doing proper maintenance, or the tests aren't stable. 28% is test data issues, like I was mentioning. And then 16% is test environment issues. So it could be a misconfiguration in that test environment, right? And that can cause problems. Or it can be the wrong data in the test environment. We're trying to use data that's in a, let's say, a local environment or a dev environment on a staging environment, and that's going to cause issues. And then 28% is real errors, right? So as this breaks down, the percentage of real errors can get pretty low, although it's higher than it's lower than flakiness issues. It's about the same as test data issues, but it's more than the test environment issues. The test environment issues, they can like they kind of would be related to the test data issues, or it can be a configuration issue in the test environment. All right, but 28% of those are real issues. Which, if we're at 16% of our tests have some type of flakiness, right? And then 72% of the test failures are false positives. Um, so this 28% actually, I'm wrong, right? I made a mistake, right? So 33% is automation flakiness or maintenance, 28% is test data issues, 16% is test environment. So out of the failures, right? 72% being false positive, there's 28% that can actually be real issues, which is kind of high. But if you have to mine through all of these false positives, it gets a bit complicated and confusing to actually catch the real issues, which kind of makes automation rendered ineffective. Which is not good. We want to reduce this 72% as much as possible. There's always going to be maybe some type of flakiness, but um, it's if out of 100 failures, 72% of them are false positives. That is a recipe for disaster. Okay, and it makes you like kind of like not trust your automation, and then you end up missing out on that 28% of the real issues. So let's keep going. So let's find out how the different tools handle it, okay? So let's start off with Playwright. There are many ways to handle the flakiness in Playwright. Following are some of the best ways of handling the flakiness in Playwright. So auto wait feature. In auto wait, we make sure when you perform an action like clicking on the element, selecting a value, and entering data into the text field, the element should be loaded before the action is performed. So pretty much when you do anything, you should have it loaded and then it's going to do the next step, okay? And let's see what it has in here. Um, below is a code snippet with the assertion. All right. So verify button enabled or not. Page locator button has text. So the button has text previous. We'll check the button is enabled or not. Expect await submit is enabled to be truthy. Await submit click, right? So this expect right here is the assertion that it's expecting that the await submit is enabled, and then you do the submit click, right? So in the code above, we do not need the line below. You're just wasting testing time on non-necessary assertions. The Playwright has an auto wait mechanism and automatically handles the assertion. So they're saying we don't need this line right here, this expect await, because it is built into Playwright to wait for the submit button to be enabled, and then it will do the submit click. Okay. Um, Use methods like wait for load state, wait for navigation, wait for selector to avoid flakiness. We can use these methods to avoid flakiness. Using these methods, we can make sure the page is fully loaded before it interacts with the element on the page. Method wait for load state is used to wait till a specific state of the page is reached. Method wait for navigation is suggested before beginning navigation. Click an element Clicking an element may cause asynchronous processing to take place. Wait for selector used to hold off until the selector satisfies the state option. Example: either appear, disappear from the DOM, or become visible or invisible. So, and this is the code for it. So you can have wait for load state, document loaded, wait for load state, network idle, wait for load state, load, and then you have the timeouts associated with it. And then the one for wait for navigation, it has page await for navigation, and you pass in the URL that you're waiting for. And then wait for selector, you're waiting for this selector of the class of myDiv to be available before you do anything. All right. So another feature using which we can avoid flakiness is retries, right? Sometimes when the page loads for the first time, the required element is not present and the test case fails. We can avoid the situation by using the retries option. We can provide the retries option in Playwright the playwright.config.js file, so that when a test case fails, the system will try again, and the probability of the test case passing is increased. So in Playwright, you just have to go to the playwright.config.js and you configure saying retries 2 times. So if a test fails, give failing test 2 retries. So, okay, if it's you put 2. If the test fails, it's going to run again. And we'll actually configure that on the live stream, our next live stream. We're going to configure the retries to be 2. So if a test fails, it's going to run the test again 2 more times. So the first time it's going to run it. If it passes, then it's not going to run it again, from my understanding. And then if it fails again, then it's going to run it 1 more time. And at that point, if it fails again, then it's going to mark it as a failure, and then we'll have to do some investigation, right? So those are the ways that Playwright handles test flakiness, right? So let's do a quick recap on that. It has an auto-wait feature, so we do not need to put in an assertion to wait for something to be enabled or displayed or anything like that, right? So it is automatically going to wait for that, so we don't need that expect line. Then we can use methods like wait for load state, wait for navigation, wait for selector, where we're waiting for the page to load, or waiting to navigate to a page, or waiting for a particular selector to be available before the test proceeds. And that's another way to avoid flakiness. And then the last way that we talked about is the automatic retries, where we can configure in the config file for Playwright, and we just pass in the number of times we want it to retry. And then if it fails, it's going to retry for that amount of times before it gives up and says, help, I don't know what to do, okay? So now let's move over into Selenium. So in Selenium, test cases can be flaky due to the flakiness in the test code or the flakiness in the test infrastructure. And that is a fact. Like I said, I've been using Selenium for the past 10 years now, and maybe more than 10 years, but it's been almost a decade that I've been using Selenium, and I have had to deal with an enormous amount of test flakiness. And we're always trying to tweak it so that it can be a little bit stronger, a little bit smarter. We've added like different type of retries. We added different wait methods. There's another issue that happens in Selenium with still elements that we, I've tried to put in so many different fixes in place. But you're still going to get some test flakiness, but you're able to reduce it drastically. Okay, so let's start reading. In Selenium, test cases can be flaky due to the flakiness in the test code or the flakiness in the test infrastructure. Flakiness on the infrastructure front can be avoided by moving test execution to a cloud platform like Lambda Test. Shameless plug by Lambda Test, of course, but I don't blame them. But yeah, it can be moved to there because the infrastructure can be a lot stronger in the cloud, whether it's AWS, whether it's Browser Stack, whether it's Sauce Labs, whether it's Lambda Test, right? I remember one time getting a really strong AWS EC2 instance and running a bunch of scripts in parallel on there, and it was super fast and it did pretty well, right? Not many flaky tests, but it just depends how you do it, okay? So a flaky test is a test that randomly passes or fails for the same code, giving inconsistent results. One time it passes, another time it fails, and the next time it passes without any change being made to the build. Okay, so that's like we mentioned earlier, okay? There are several ways to avoid flakiness in Selenium tests. Use stable selectors. Like I'm a big advocate for using good selectors. Instead of using dynamic selectors such as XPath, try to use stable selectors such as a class name or an ID to locate elements. Dynamic selectors can be affected by changes in structure of HTML, leading to test flakiness. And that is so true. And that's why, as QA engineers, we have to be advocates for good testable code written by the software engineers, right? A lot of times, the engineer just write like HTML code for the application to function, but it's not testable. And when it's not testable, it easily leads to the engineers making a change, and then things start to break, and we're not able to properly test it because we don't have a good automated test in place because the website wasn't written to be testable. And that's one of the things that I'm communicating to Calculus Coder, to Jared at Calculus Coder about, is like, okay, your site is awesome. It is very valuable. It is great. However, we need to make it a little bit more testable by adding some test data IDs that aren't going to change, that we can easily identify these things. And as soon as that's done, then we can go back and we can update our tests to have a lot cleaner selectors, because the way that we had to do it, it was not a very good implementation that we had to do for the automation side. But that's due to not having good selectors to use from the software development side. So and that's how QA engineers and software engineers can collaborate together to write clean, testable code. And now the code is good, or the code is testable from the software engineering side, and we write nice, clean tests that are less flaky, and that now we have a good cycle. So the engineers, they write some code, and they say, okay, it's ready for testing. Now we run our automated test, which does regression, and now now we have a good cycle going. So as they put new features, we add new tests, but the old tests keep us honest, and they'll run and make sure that nothing else has broken. The automated test written by the Q engineers it's an extension of the unit test written by the software engineers, right? Because the unit tests are testing the smallest units of code, and then the automated tests that we write start connecting things together to make sure like things are working as expected. Okay, but in order to accomplish that, we need to have testable code written by the software engineers. Okay, so the next thing is use explicit waits. Instead of using implicit waits, use explicit waits to allow the page to load and stabilize before interacting with elements. This can help prevent tests from failing due to elements not being immediately available. Then there's add a retry logic. Implement retry logic in your test to retry failed assertions a certain number of times before giving up. This can help reduce flakiness caused by temporary network or server issues. And the thing about adding a retry logic to Selenium is you have to code it yourself, right? Unless you're using a Selenium framework that has it built in, right? Because I've created Selenium frameworks before using Java, and I wrote the retries into it. But there's different levels of retries, right? You can do a retry on a failed assertion. You can do a retry on a exception that you get. You can do a retry on the whole test. So you say, okay, all the tests that failed, let's run them again, right? And then you can have a retry on that. Okay. Use a stable testing environment. Make sure your tests run in a stable environment with consistent network and server conditions. So if you're running on a network that goes down from time to time, it's not very strong, it's slow, then you're definitely going to get errors, because like it might be waiting too long, or it might time out, the page might never load. So we need to make sure that we're using a stable testing environment, and it has to be accurate for all the different environments we run. Because let's say we run it locally and it runs great, then we run it on a dev environment, which is kind of weak, and then now we have inconsistent results. But then you run it on a staging environment that is a lot stronger. So we just need to have the same type of consistency across environments to make sure that that everything's on the up and up. Okay. And then we have debug failing tests. When tests fail, take the time to debug and understand the root cause of the failure. This can help. This can help you identify and fix underlying issues that are causing flakiness. So definitely, you got to debug, see what's going on. Use a test framework. We mentioned that a little bit earlier, right? Use a test framework such as JUnit or TestNG to structure your tests and provide built-in support for handling test failures. This can make it easier to identify and debug failing tests. And as you get more advanced, you can start building your own frameworks that are built on top of these like baseline test frameworks. And which, when I say baseline, I don't mean that they're like not good or anything like that. They're great, right? But you can enhance the features that way. Okay. And then it says use a reliable testing framework. Use a reliable testing framework such as JUnit or TestNG to manage the execution of tests and handle any issues that may arise. Right. Then we get to use a reliable continuous integration CI server. Use a reliable CI server such as Jenkins or Azure DevOps to run tests automatically and track the results of the run. And you can also use like TeamCity, Jenkins. Oh, it mentioned Jenkins, right? But you can use like TeamCity is another one. There's Circle CI. I haven't used Circle CI yet, but I am interested in finding a little bit more about it. But I have used TeamCity. I haven't used Azure DevOps yet, so that's another thing to look into, which we'll definitely do that on a live stream at some point, because I definitely do want to get into Azure after we're done getting very familiar with AWS, because the more that you can add to your arsenal, the deadlier that you are as a QA engineer. Okay. So one way to use a cloud platform like Lambda Test to avoid flakiness in Selenium is to run your Selenium scripts on the cloud infrastructure instead of running them locally on your machine. Yeah, because the cloud infrastructure is always going to be much more powerful than the machine that you have. In most cases, right? You might have a Mac with 96 gigs of RAM, and that's a different story. That's a whole different beast. But the key is that you want to go for cloud infrastructure. You want to free up your machine so you can focus on development and not executing tests, and then you can get a more consistent and reliable response that way. Okay, so I hope that the Selenium overview gave you some valuable insight, and that it helped. But we are about to jump into Cypress before we wrap it up. So Cypress handles flakiness. And by the way, before we go on, right, Cypress actually, to my surprise, handled the automation of the free mind recovery site a lot better. When on the first live stream it wasn't working, but then on the second live stream it started working, and it handled like running the automation a lot better than Playwright and Selenium did. So right now Cypress is in the lead. But we'll see how Selenium and Playwright pan out in our next stream. But that was interesting for me to see that, like, after having some initial trouble with Cypress, it actually was the only one who got as far as it did the other day. Okay, so Cypress handles flakiness very well. In Cypress, there are different ways to perform flakiness or to handling flakiness. Right, following are some of the best ways of handling flakiness in Cypress: adding dot contains and then the element, and then should be visible, and then should exist. So those are the different ways that you could handle flakiness before clicking on element, right? And then you can do test retries, just like the other frameworks. And then you can use timeouts instead of waits, and then use side.intercept to wait for the XHR request to finish. Okay. So the first and very straight way method to reduce flakiness is by using dot should exist, using dot should be visible, using dot contains element, right? These assertions reduce the chance of test case failure. The second method in Cypress to reduce flakiness is to use test retries. You can set the retries option at global configuration, individual test, or test suite level. So it gives you a little bit more options, right, of how you can set it up. Um, but so we have retries run mode, default is 0, open mode, okay. And then another way to reduce flakiness is to use timeouts instead of waits. Sometimes we have required a higher timeout for a particular element to load into your page. You can wait, you can handle such cases by providing a timeout in a particular element instead of using side.wait. The difference between side.wait and set the timeout at the field level is, in the case of side.wait, Cypress will wait for the complete time that we have provided until side.wait. But in case of timeout, if the element load before the specified timeout, Cypress will move to the next command to execute. This way, sometimes timeouts is effective and it saves time. So let me read that one more time just to make sure I understand it, because like, I'm still new to Cypress, so I just want to make sure I understand it a little bit better, right? So the difference between side.wait and set the timeout at the field level is, in the case of side.wait, Cypress will wait for the complete time that we have provided under side.wait. Okay. Oh, so okay. So what that means is, when you use side.wait, if you say wait for 30 seconds, it'll wait for the full 30 seconds and then it'll proceed to the next step. But in the case of timeout, if the element loads before the specified timeout, Cypress will move on to the next command to execute. So what that means is, if you set, like, so in the example before, the timeout of 10 seconds, if the ID for first name loads in 5 seconds, then after 5 seconds, it's going to proceed to typing Mike. But if you were to use side.wait, it would wait the full 10 seconds before doing anything, which would take the script longer to execute. Okay. And we're trying to get to it as fast as possible. Right. So we can also use side.intercept to wait for the XHR request to finish. We can intercept the particular network call and till the call is wait till the call is not finished. I think it means until it is finished. Right. In the below screenshot, after waiting on the form model, we presume there is some unfinished request. Sci.wait waits for the request/response cycle to be complete. By using sci.wait at get model, we have access to the XHR object. Cypress will wait for the API call to end before moving forward as long as a request is not finished. So you can prevent test cases from failing in this manner. So okay, so maybe I did mean until the call is not finished. From continuing to read this, so maybe I'm wrong about that. Okay, so let's see what that means. Wait till model is not open. Let's see. All right. So yeah, so we'll do a little bit more about that because I think with the get model too, like because the XHR, you get to interact with the network calls, the API calls that is being made in the browser, and you can work around that as well. Okay. So that is how Selenium, Playwright, and Cypress handle test flakiness. Next time we'll be getting into the screenshots about the importance of screenshots and how the different tools handle screenshots and potentially video recording. But that is it for this week. We were talking about the test flakiness, giving a full breakdown of how flakiness happens and how these automation tools are using their features to try to reduce the chances of flakiness and to give better results. So you're not ending up wasting a bunch of time investigating issues that failed when they should have really passed. All right. So that is our episode for this week. Hopefully, you found that helpful and informative, and you've learned a little bit more about automation, the automation tools, and about dealing with test flakiness, which is something that all QA engineers have to deal with, but we will persevere. Okay. So let me know what you think about the video. Did you find it helpful and informative? If you did, I would encourage you to go subscribe to the channel, Tech Coach Ralph, and to hit the notification bell so you can know every time we go live or drop a new video. And while you're at it, go ahead and like the video, share the video, drop me a comment, or leave me a message in the chat. And if you want to level up your technical skills and you are looking for one-on-one coaching, I would highly encourage you to go check out www.techcoachralph.dev. And if you're looking for other ways to connect with me, check out connect.techcoachralph.dev and see all of the different ways you can connect with me. All some additional resources that I provide, such as the time cost calculator, and more coming soon as my team continues to develop out more and more useful resources. All right. So with that being said, thank you for tuning in. I hope you found it helpful, and we will continue, and I will see you guys next week. But until next time, this is Tech Coach Ralph, where we are engineered to win, signing off with another episode of Software Explorations.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.